everyone. Lot of great day today. Today, I will be talking about why building AI agent is as much as an art as it is the science. And we have heard a lot today about the science. It's a pleasure to be here in a room full of engineers and data scientists. And you will certainly bring the technology hat, but I have an ask. I want you to also be a customer. And by now, you know, at Target, customer, we call it as guest. So be my guest today. So, every guest interaction, every contact that our customer does with us is an opportunity to build trust, build loyalty, and earn that next visit. And service is one of those places where promises are either kept or broken. And that's why we don't call it as a call center or a contact center. We call it as a service center. Every year, our service center supports nearly 20 million volumes across different channels, serving our guests, team members, and partners. And each of this is powered by 3 core pillars. Build best-in-class guest-centric experience, deliver effective, trusted, high-quality support, and run operations efficiently. Last year, we processed nearly 6 million of chats through our AI agents, achieving a containment of 48% and reducing 11% of average handle time for our agents. Now let's see how this all was enabled by the tech. Now, as we started our journey, multi-agent architecture was a clear and right choice for our area. And most of us, we assume building a right prompt, selecting the most beautiful reasoning model, and giving the right tools will achieve success for us. But in our experience, there are 8 key ingredients to make your AI agent scale at an enterprise level. Today, we will not be able to talk about all the 8s, but we will walk through some of those. And as I talk about those, I will intentionally use just 1 or 2 use cases so that you can understand the complexity. And as I do about those, I hope you will be able to relate it with your respective domains. So, let's start with. A typical multi-agent orchestrator looks very simple. A contact comes, an orchestrator understands the intent and routes to a specialized agent. Now, think about a guest calling us to return a book. The orchestrator routes it to a return agent, because that's the right specialist. On slide, looks great. Pilot, it works. Reality is where the real engineering begins. What we think a return agent, it is not just doing a single item return. It could be multiple item, multiple order, single order, multiple shipments. At Target, we have national brands, the policies are different. We have our own brand, the policies are different. We have our marketplace and third-party brands, and the policies will be very different. So think about the return agent. When you have those policies, decision-making, it's much more larger in size. So the small specialized agent, what you saw, is truly not small. So where we started was prompt engineering, not a surprise. And we started our return agent with just 150 lines, and it was doing an awesome job because the models were reasoning well. As we started adding decisions, guardrails, all the different scenarios, adding few short examples, it just started looking like a large legal document, hard to maintain. And not just that, it started changing the agent definition from what it should do to what it should not do. I believe most of you have been in that in our instruction we write, do not confuse, do not do this, or do not skip this step because those are more essential in your journeys. And you intentionally do that for your prompt. And soon we realized prompts are not substitute for your architecture. The more you try to control with your prompts, the more challenging it becomes. It increases your cost, it increases your token size, and much more larger, it increases your latencies. Because when you're interacting with the guest, latency matters the most. As we started, the industry evolved, and so did our design. We started exploring what are the options, and certainly you have heard workflow orchestration. They give us control. They allow us to do different steps. And it ensures that all the steps are adhered, compliance is met. Now, from a technology perspective, the solution works. However, think it from a guest experience perspective, it still starts feeling deterministic in a conversation. So every guest path might not be same. Every guest may end up with a different path in a return journey. The workflow forces it again and again to go through every step again and again. The other option was to create more agent nodes. You create more sub-agent nodes. And as you start thinking about it, it just creates a massive agent ecosystem, hard to maintain, hard to govern, hard to handle. So, in short, too much of prompt becomes fragile, too much of workflow becomes rigid, and too many agents becomes operationally expensive, especially you are scaling at a distributed level. So the paradigm shifted from context engineering to context engineering and building agent skills. And most of us thought, like if we build agent skills, things would work. At Target, we started using a technique called progressive context disclosure. And it is all about giving the right context. Let's take the same example, return agent. When you start the journey, the first task the return agent has to do is get the order information, get the item information, what is the quantity to be written, and the reason why we want to return. Now, that could be the only task you want the return agent to know and not know the entire return journey at that point of time. And once that task is completed and validated, that's when you disclose the next context to it. So, right context matters, but also the right time. And there is a third dimension, what we believe it at Target. Along with the context and the timing, there is the right source. Let's take another example. A guest calls saying, hey, the item is showing delivered, but I did not receive it. The AI agent goes, checks behind the scene, it executes the tool and says, hey, we are able to see the delivered status. I have the proof of delivery. It responds back to the guest saying, hey, here is the date when it was delivered, here is the proof of. The guest is still frustrated. I don't know where you delivered it. I did not receive it. Get me a full refund for it. The AI agent goes back, checks to the tools, invokes the refund. Certainly, refund is not eligible because the product is delivered and we are not doing a return. Now, the tool can do a lot of other decisioning because it can do the guest profile understanding, context understanding, emotional understanding. The entire thing it can understand, and because Target is guest-facing, guest-centric, and we value the guest, sometimes it's more meaningful to give a concession or a refund. And how much you give, how you refund, that could be a next context that is disclosed by a tool. Majority of us, we believe, tools are just JSON formatted API abstraction. It returns a thing of JSON. But tools are most powerful in your multi-agent ecosystem. They allow you to do a lot of deterministic work, and based on decision, allow your agent to do the next best action. So, what we learn, sometimes the context comes from your actual agent journey, sometimes from your tool, policy, or a guardrail. So, context, it is a choreography. It should know when, which step, and from whom. And that, delivering it is a true art, not just the science. Let's talk about the next frustrating thing in the multi-agent ecosystem because handoffs are pretty common. As engineers, we all love loops. Many of us talk about loop engineering. Some of you are doing loop engineering in coding, long-running agent processes and everything. But as a customer, when you are hearing from AI, would you prefer a loops, a repetition? No. So let's take it as an example so that we can relate it. Someone calls for an order return. The AI agent understands that, hey, it is for the order return, and the issue is associated with the price because a guest found a better deal somewhere else. Now, technically, order return can complete the return. But from a business experience, and because we value guest, we don't want to lose the sale and the loyalty. Rather, we would offer a price match. So the order return agent may simply say, hey, would you be open for a price match? Guest says, yes, why not? It handovers the entire context to price match agent, and the price match checks all the eligibility and then determines the order is not eligible for price match because it has, not meeting all the policies or things for the price match. In that, the guest says, okay, in that case, I want to return. It comes back to the order return. So now we have created this loop. It might not be just between two agents. It could be 3, 4, I don't know how many agents you have. So to solve this problem, Target built a loop guard. And it is a key component in every agent which ensures a right entry and right exit conditions are there. Now that certainly is still a science. There is also an art component of the loop guard. Let's take the same scenario again. I started with returning a Harry Potter book, and I completed that journey. In the same conversation, I continue, and I complete a Pokemon card price match. I don't know why my son loves Pokemon card, but he loves. So we complete the price match journey, and then I start to return my jeans. So these are 3 different valid journeys completed. The cycle is same, but this is not a loop. The system should not detect this as a loop. So the loop guard should be distinguishing between a valid new journey and a repeated unresolved cycle. And that is not just science, it needs to understand the art of it. So customer likes progress, and the goal is to make progress intelligently and not get into an endless loops. So, a lot of conversation about memory today. And we know, all of us, memory is a very key component. And most of you would have built some of other memory in your agentic experiences. There is state, which is live session context, short-term memory, long-term memory. Science is pretty clear. We will use a key store, vector database, or a graph database, apply semantic search. To ensure your memory is managed well, you use compaction strategy and everything. You continuously do the summarization and everything. Most of us believe memory is just a storage problem. But at Target, we believe it's a judgment problem. So, let's take an example. A guest calls for a return of an item, and it goes through identifying which item and all that stuff. Mid of the journey, the guest changes the mind. Hey, I changed my mind. I want to exchange instead of returning a journey. At that point, you want to carry the memory. It creates more token size, obviously, more cost, as Brad shared a lot of that today. And much more than, it creates a noise and confusion in memory, and that's where some of the hallucination happens. So memory is not just about what to remember and what to store. It is also about what to forget and what to not carry. Memory is also about what is the right context you should carry across your boundaries of your agents. And that needs an art problem and not just a science problem. So, we all know guardrails are very essential to use AI very responsibly. At Target, we have a centralized platform called Think Tank. And it's one of our foundational agentic platform enabling, activating all the agentic experiences at Target. And centrally, it does moderations. It has many shared services, and one of them is the moderation services, where all your key guardrails, whether it is PII, prompt injection, fraud and abuse, are managed and detected pretty well, handled pretty well. But beyond your centralized guardrails, every agentic domain-centric guardrails will be needed. So let's take that by example. In the service center, because it is a retail service center, if a customer asks our agent saying, hey, can you talk about our competitor information? Certainly the agent is not supposed to talk about that and handle it very gracefully. But within Target, a legal agent, which is helping with a lot of legal research, is asked about a competitor information. Certainly it should get that information and give it. So you would have at an enterprise level guardrails, you would need a domain-centric guardrails, and on top of it, you will also need an agent-centric guardrails. So within our TES service centers, some of the journeys when we are talking, If it is a safety or injury-related issues, you don't want AI agent to handle it. It should immediately escalate it to a human. It is not a policy decision. It is a commitment from us to our customers that we want a human interaction there and not AI talking to that. So, as you see, we need to build multi-layered guardrails. Now, that brings a very complex problem. It increases your latency. So, the art is all about which guardrail should be built where, in which layer, and one should clearly understand that. And beyond that, which guardrail should run sequentially and which guardrail should run parallelly, so that you don't have the latency problem. And at Target, we do that very intentionally on saying which guardrails need to be layered rightly and executed parallelly. There was one more important lesson which we learned in this. Not every safety net should be a guardrail. And that's much more important. So take our price match or a return agent guardrail. We have empowered our AI agent to do it only below a certain amount, dollar amount, because there are certain things which we don't want to empower intentionally to our AI agents. Now that one can consider from a business context perspective that this is a guardrail for the journey of a price match or a return agent. However, these are best executed within your tool more deterministic, because the more you put it in your guardrail, the more token cost and latency it will add. And these are non-negotiable, which you should execute it more deterministically. So by now, with all those things, we have understood there is certainly a science which is all about models, architecture, everything around what you are building about within your AI agent ecosystem. But there is also an art in deciding the behavior for the real guest in the real world and for those real moments when you need those experiences. When you start thinking about scaling AI agents, there is a systematic change which we need to do it. Agents building is not just about the prompts. Agent building is building your workforce. And if you start rethinking about it, your models are the machine, not your agents. Your agents are the worker. Tools are the capabilities. Guardrails are your policies. And the outcome which you are truly delivering by agents is the guest experience. So every one of us who is building agents should start thinking differently. We are not doing system designing. We are doing workforce designing. We should start shifting from system architecture to workforce architecture, from a system integration to workforce collaboration, because that's what is all about multi-agent architecture. So the future of AI enterprise will be won by the teams that combine both the science, bring the best in class of the science, but also the judgment that is needed for running your multi-agent ecosystem for delivering the best in class guest experience. Thank you.